Video 46, what I'm hoping to show today is the concept of block hashing. The manual, as always, is fully descriptive of this, so please refer to that for the kind of the authoritative explanation on it. But a very simple explanation is, let's take the scenario that you have a file, a sample file that's been passed to you or whatever, and you've been asked to try and work out if that file or any fragments of it appear anywhere else within your organization or wherever it is you have to look. Now the normal way of doing things with most of the time is that you would hash that file and then you would look for the corresponding hash on the other devices that you've got to look for. And that's all well and good if the file that you've been asked to look for and its hash value are in the same form on the other machines. But what if they're not, and they've been deleted, partially overwritten, and there's only a few bits of them left over? Then finding the hash of them won't work, and doing keyword searching could be a long withdrawn way of finding bits that you don't actually know if they exist at all in the first place. So block hashing is the answer to that problem, and it's one of the most impressive new features to X-Ways Forensics in my opinion. And what I'm hopefully going to do is show how that's worked. What I've set up already, I've created, I've got a USB drive and I've downloaded some information about guide dogs, and I've copied about 12k of text from one of them and whacked them into a text file. And those files, as you can see, are live on the file system as normal. But what I've done is I've taken a few K of this file, some text 1. I've taken a couple of sectors of data from there and written it to the free space of this device. Now obviously in the scenario that I gave earlier, some text 1.txt wouldn't be on the same device as what you're looking for. It'd be that file that you've perhaps been emailed or you found on some other machine or whatever. The demo is restricting me a little bit as to exactly what I can show. So what I'm going to try and show you is, using block hashing, is how we can find the particular fragments that I've put in the free space. The first thing to make sure you've done is, under your hash database, it's important probably to ensure that any previous block hashes that you might have from other cases perhaps aren't littered around. I say important, you know, you can probably distinguish between them, but it might make things a bit slow if you've got thousands of others in there. So under block hashes you might want to go initialize just to clear all of that out, not that I've got anything in there anyway. Then what we need to do is we need to instigate a block hashing process to populate the hash database with the particular sectors of hashes from these files. So this particular file is the one I'm looking for, so I'm going to right click it and choose create hash set, and it will ordinarily default to one of these up there, but I've just been messing about with it. To ensure that it's created as a block hash, you choose block hashes down there, and you can give it a name of whatever you like, but I'm just going to leave it as the name of the file. So we click OK, choose MD5 for the sake of argument. And so what that has now done is it's gone through that file sector by sector and created MD5 hashes of each particular sector and put them in a hash database called SumText. Now what we can do is, if we go refine the volume snapshot and choose block hashing, and just for completeness, not that I need to do it, but I'm going to choose to compute the hashes of the files in my case as well, so we get the full hashes, and just make sure that the whole thing's chosen, which it is. So we click OK to that. It's saying which block hash set do you want to match against. Well, I'm going to choose that one, and off it will go. So it will now look for all the various bits of sectors that are in that file, or right the way across the disk. So when it says complete, you're expecting to see results. The way to see the results is to use the search button here. So you click the binoculars, and what you will get in a positive there are some positive hits, are the references that we were just talking about. So this file here, if I click on that, let's say file, it's not actually a file, it's a search hit, you'll notice that it's found half a kilobyte, i.e. 512 bytes, in the free space, and this here is the portion of text. As you can see, it's surrounded either side by zeros effectively, or FF in this case, and that's just the little portion of text. And you might say, well, how do I know that was in the original file? If I just skills and experience, if I just go out of the search mode again and click on this file, I'll look at it in preview mode for you for a better idea. Somewhere in here, I'm fairly sure. Yeah, there we are. So this bit here, skills and experience, ability to demonstrate you can work, blah blah blah, is in there. Skills and experience, ability to demonstrate you can work, blah blah blah. So that's a very simplified demonstration of block caching. Hopefully useful to you. Like I say, as far as I know, XOA is probably the only forensic tool that does this. Certainly at the moment, I've got no doubt that others will follow in their footsteps.